Dear student, as exact linear phase is a dominant advantage of FIR filter, so we should know what is a condition of exact linear phase. In order to understand that, we should start with the transfer function of a practically realizable FIR filter. Practically realizable FIR filter means the filter must be causal. The transfer function is expressed by the formula where Hn is the impulse response of the FIR filter. If we see the frequency transform of that, we will have a expression in this form where h e raised power j omega is a periodic function with period of 2 pi, and because this h e raised power j omega is a sum of number of terms and each term is a complex number. So basically h e raised power j omega is a complex number. This complex number can be expressed mathematically in the form like the magnitude of the complex number and its phase. This magnitude of the complex number is termed as magnitude response, whereas phase of the complex number is termed as phase response. We are saying this response because it is a function of independent variable omega, which is a distal frequency. So these two are the functions varies with respect to the frequency, so we use the term response. This is a magnitude response, this is a phase response. Two new terms has been introduced here. One is a phase delay, another is a group delay. Phase delay is the ratio of phase response with respect to the distal frequency. Minus sign indicate to delay, whereas group delay is the differentiation of the phase response with respect to the distal frequency. So, if a FIR filter have linear phase, its meaning is that the distal frequency and phase response must have a linear relationship. This linear relationship can be expressed in terms of a linear equation, just like y equal to mx plus c. In this case, c is 0. If we take the linear equation form like y equal to mx, so this linear relationship can be expressed as with a constant with a proportionality constant alpha, and in this case we can see that this phase response is very linearly with respect to the distal frequency. Alpha is a proportionality constant. It is termed as constant phase. Minus sign indicate the delay, and we are very much familiar that the distal frequency always lies in the range of from minus pi to pi or 0 to 2 pi. So we must remember this thing here. Now, when you find out with this linear phase condition the value of group delay and phase delay, you get that in this condition phase delay and group delay will be equal to alpha, which is a proportionality constant here. Further, now from the Fourier transform expression as well as complex number representation, when we equate h e raised to the power j omega from the above two equation, we have this relationship where we may separate the real part and imaginary part, and after separating real and imaginary part we may achieve the two equations, and further mathematical manipulation will lead to a term that will have certain left hand side and right hand side. Right hand side of this equation is equal to 0. In order to equate, the left hand side must also be equal to 0. How this left hand side will be equal to 0? When each and there will be the different conditions. First, because this left hand side is a sum of n number of terms, so if this left hand side is 0 means each and individual term should be 0, then only the summation will be 0. When each and every term will be 0, either hn will be 0 or sin alpha minus n will be 0, minus n omega will be 0. If hn is 0, if we assume hn is 0, it means there is no impulse response, means no filter. So it is not be the solution. So hn cannot be 0. Now we come on to sin alpha minus n omega. We know the sin term varies sinusoidally like this. Okay, so this is a sine term, means in this expression we will, when we put the different value of n, we will get the different value of sine, because sine in the range of 0 to 2 pi, the variation of sine will be like this, means it will have equal and opposite component for its samples. So this sample and this sample will be of equal and in equal length, but in opposite sign, equal amplitude, in opposite sign, equal amplitude and opposite sign. So sine term will be like that. So individual, if we want to make individual term, the summation of individual term equal to 0, means if we are multiplying this sine term, suppose it is the sine omega, if we multiply it by h1, so if h1 is 3, so in this case 3 sine omega will be the one term, and because at this particular expression we get the same amplitude at this 4 omega position of the sine, so if we multiply to the same amplitude here, means minus 3, the amplitude is same here, but this sine term has a opposite in magnitude. So suppose this amplitude is certain value a, so this a here will be minus a, and this amplitude is plus 3. So means 3a and minus 3a will cancel out to each other. So the meaning here is that if a sinusoidal term is multiplied by certain term, then this term should have equal amplitude at the opposite position, so that overall sum must be equal to 0. Okay, then only this condition can be achieved. So the conclusion from this point is that hn and hn minus 1 minus n means just opposite terms. When you put n equal to 0, small n equal to 0, you will get hn minus 1, means first term and the last term. So opposite term should be equal in amplitude, and when these opposite term will be multiplied the corresponding sinusoidal term, because sinusoidal term is already in opposite but equal in magnitude, so these terms cancelled out to each other. So with this condition we will achieve this relationship, and it is a very important relationship, that the symmetry lie in the impulse response of a FIR filter when we want to design the exact linear phase, and the symmetry of the impulse response will be specified by the center of symmetry, which is indicated by alpha. Alpha will be here equal to n minus 1 by 2, that is half of the length. So if we consider two different value of n at this particular point, means when n is even and when n is odd and when n is even. When n is odd, the symmetry lie on one of the middle sample. That can be clearly illustrated here, and in the case of n is equal to even, the symmetry lie midway of the samples but not on any sample. So this is a thing that you have to remember, that when you want to design the exact linear phase FIR filter and the linearity follows by the equation y equal to mx, means in this case group delay and phase delay both are same, equal to the proportionality constant alpha, and the impulse response of the designed FIR filter should have symmetrical response. Okay, so this is a symmetry around the center of symmetry, so it should be obeyed by the designed FIR filter in order to achieve the exact linear phase. The other condition of linearity is if the linear relationship is specified by the y equal to mx plus c, where c have some finite value. Means if we represent by some phase beta in this equation, so in this case phase response varies by the relationship as minus alpha omega plus beta. In this case, when we find out the phase delay and group delay, we will see that the phase delay is not a constant value now, but group delay is a constant. In such condition, again, just like the previous mathematical steps, we follow all the steps in this case too, and find out the final relationship will appear in this form. Okay, here beta and alpha, two terms are there. Again, to make the equality obeys, we have to make this right hand side should be equal to 0. Again, Hn cannot be equal to 0 because it means that there is no filter. So the equal and opposite number or the term should be cancelled out to each other. So to just like the previous case, here we will see there are the two terms beta and alpha. Beta is fixed when we make beta fixed at pi by 2, and in this case it will convert into the cos, means now we obtain the cos function here, and in the case of cos function the response will be like this. Start from 0 to 2 pi, the response will be like this. Here we will see if we take the different cos values, means all have equal magnitude at the opposite end. Okay, so this equal to this, similarly this equal to this, and this equal to this. So the amplitudes and their signs are equal. So when this is the case, in such condition Hn must be of opposite sign at equal and opposite end. Okay, at opposite end Hn must be of different sign but equal in amplitude. So this condition will be here, and again center of symmetry will be half of the length of the filter. So the conclusion here is, whenever you design a FIR filter with constant group delay and not constant phase delay, in this case impulse response is anti-symmetrical. With this condition we also get the linear phase designing of FIR filter, and means the constant group delay but not the constant phase delay. In this case the impulse response is anti-symmetrical. When both are constant and same, then the impulse response should be symmetrical. So again we will see for n equal to 7 and n equal to c, as the impulse response should be like this, equal amplitude but opposite in direction, and thus at the center of symmetry the value is 0, means this is a condition for anti-symmetry odd sequence Hn minus 1 by 2, means the sample at the center should be equal to 0. But when n equal to 6, the center of symmetry will not lie on the sample, so this is not the condition. But in n equal to 7, which is an odd number. One sample lie on the center of symmetry, so this condition obeys in this particular case. And on this basis we can solve any question as I have solved here. If a difference equation is given to you, if a difference equation given to you, you can find out this impulse response, is frequency response. With the help of frequency response, you can find out the magnitude and phase response. So the whole frequency response is expressed now in terms of its magnitude and phase. From there you can find out the theta omega, which is equal to minus omega here. And if you have to find out the phase response, that will be minus theta omega upon omega. So put the value of theta omega, it will be plus omega now, and it will be 1. And similarly, when you differentiate this theta omega with respect to omega, you have to differentiate with respect to omega, you will obtain minus is here, so minus 1. So this is equal to this. So in that way you can solve any numerical based on this. Thank you.